This is part 1 of exponent rules. We're going to go over a couple of examples dealing with multiplication and power of a power just to make things clear. It's really easy to get all these confused, so I want to explain why they all work in case we don't have time in class to go into too much detail. So for the first example here, we have x squared times x to the third. When we multiply two terms with the same base and different exponents, exponents don't even have to be different. You just add the exponents when you have the same base. So we know, using that rule, that this answer is going to be x to the fifth power. But why does it work? The reason why it works is because looking at this first term right here, the definition of x squared is the same thing as x multiplied by itself twice, which is x times x. So I'm going to go ahead and write that down right here, x times x. Putting a times there because we are multiplying by this x to the third. That's the same thing as taking x and multiplying it by itself 3 times. So that's the same thing as x times x times x. So now looking at it, how many x's do we have? You can see that when you count that we have 5 x's. That's exactly why it works. So we can just add up the exponents and have x to the fifth power. Unless you are asked to explain the rule, you do not have to show this work on a test or a quiz. So looking at the second example, it's the same exact thing except our bases are not the same. Looking up here at the previous example, we had x squared times x to the third. Here we have two completely different bases, so nothing happens. It just ends up being x squared times, or not even times, let me go back and erase that here. Just x squared y to the third. You can combine it all and make this whole thing one term. You can't do anything with the exponents because the bases are completely different. So that is the product of powers rule, pretty much summed up why it works. The next example is power of a power. So notice how here we have an exponent and here we have another exponent right next to it. It's usually separated by a set of parentheses. Looking at the first example, we actually had a base, a variable, in between the two exponents. So here, the reason why this works is the same reason why this works up here. So I'm taking a squared and multiplying it by itself 7 times. That's the same thing as a squared times a squared times a squared 7 times over. I'm not going to have enough room to write all of that, but that is essentially why we end up multiplying the exponents. So if you have any further questions about that or you would like to see more detail, go ahead and respond to this video and we can post it right up there for you. So looking at this next example, it's the same idea. We have parentheses. Everyone's always afraid of parentheses when it comes to exponents. Here you have an exponent of 4, but this is a product. So we're taking the power of a product. Product means you're multiplying two things together. In this case, you're multiplying r and s together. So in a sense, you're going to go ahead and distribute this exponent to both factors. So this is going to be the same thing as taking this fourth power, bringing it to s, bringing it to r. So our final answer is actually going to be r to the fourth, s to the fourth. And that's fine and good, you know, because when you distribute, that works. We end up having each variable having an exponent. But then there comes a problem. So this next example, I have the same thing except I threw a number in there. I changed the exponent just for some variety here. So there becomes a problem. The problem is the most common mistake. So please pay attention to this part because I don't want you to make this mistake. People will say, oh, let me go ahead and distribute the exponent. So we do just like what we did in the previous problem. And then what people will do is they will multiply 3 times 2 to get 6. But the problem with that is we have an exponent here. That stays an exponent. It never changes. So it actually ends up being 2 to the third power, r to the third power, and s to the third power. So we're not multiplying 3 times 2. We have 2 to the third power. That's a completely different answer. So our final answer is going to be 8 once we simplify the 2 to the third power. r to the third power, s to the third power. So that's the difference between having a completely different coefficient. So if you have any questions, like I said, go ahead and respond or reply to the video and we'll get on that.